In an experiment for the determination of the focal length of a thin convex lens है ये. The distance of the object from the lens is 10 plus minus 0.1 centimeter. So ये plus minus 0.1 is actually quite small in comparison with 10. And same thing we see with this also. And the distance of its real image from the mirror lens is 20 plus minus 0.2 centimeter. ये भी है ना जो error है, this is also quite small with compared to 20. The error in the determination of the focal length of the lens is n%, the value of n is. तो सबसे पहले लेंस का फॉर्मूला लिख लेंगे 1 by v minus 1 by u is equal to 1 by f. ठीक है, अब इसको ठीक है, अब ये थिन कन्वेक्स लेंस है तो u हो गया -10 सेंटीमीटर इस केस में, प्लस माइनस 0.1 है, और v हो जाएगा, v क्या है, रियल इमेज, तो रियल इमेज, तो देयरफॉर v इज इक्वल टू +20. तो अब इसको डिफरेंशिएट कीजिए, तो dv बाई वी स्क्वायर माइनस प्लस du बाई यू स्क्वायर इज इक्वल टू df बाई एफ स्क्वायर. हमको क्या चाहिए, हमको चाहिए df बाई एफ चाहिए, फोकल लेंथ का हमको एरर चाहिए इन परसेंटेज. तो देयरफॉर df बाई एफ हो जाएगा f इंटू du बाई यू स्क्वायर माइनस dv बाई वी स्क्वायर. ठीक है, तो अब इसका मतलब कि f निकालना पड़ेगा, तो f निकालिए. 1 बाई एफ इज इक्वल टू 1 बाई वी, दैट इज 1 बाई 20 प्लस 1 बाई 10 विच इज इक्वल टू 20. 1 प्लस 2 3 बाई 20, f हो जाएगा 20 बाई 3. ठीक है, तो df बाई एफ परसेंटेज में, तो df बाई एफ इज इक्वल टू 20 बाई 3 इंटू डी बाई. अब देखिए जब हम लोग एरर निकाल रहे हैं तो ये सारा कुछ पॉजिटिव ही होगा. ठीक है ना, एरर में जो है सारा कुछ पॉजिटिव ही होता है. तो डी यू बाई यू स्क्वायर. ठीक है, तो डी यू क्या है भैया, ऑब्जेक्ट 0.1, तो 0.1 डिवाइडेड बाय 10 इंटू 10, और ये भी अब प्लस होने वाला है डी वी, दैट इज 0.2 डिवाइडेड बाय 20 इंटू 20. ठीक है, इंटू 100. तो अब ये कितना हो जाएगा, है ना, ये 20 इंटू 20, तो बेसिकली इसको हम लोग यहाँ पे ऐसे कर सकते हैं 20 बाई 3 इंटू ये 0.1, तो ये इंटू 20 इंटू 20, तो 0.4 डिवाइडेड बाई 20 इंटू 20 हो जाएगा. ये 0.4 प्लस 0.6 डिवाइडेड बाई 20 इंटू 20 इंटू 100, दैट्स इट. 20 कट गया, ये 6 का 10 नीचे, ये हो गया 2, 200 बाई 200 दैट इज 1. आंसर हो जाएगा 1%. सो द वैल्यू ऑफ वेन्स two capacitors with capacitance values C1 that is 2000 plus minus 10 picofarad. यहाँ पे भी देखिए जो एरर है this is quite less. ठीक है, and C2 equals 3000 plus minus 15 picofarad are connected in series. The voltage applied across the combination is V equals 5 plus minus 0.02 volts. Okay, the percentage error in the calculation of the energy stored in this combination of capacitors is, तो सिचुएशन जो है इट्स समथिंग लाइक दिस. ये दोनों सीरीज में है, तो दिस इज V, दिस इज C1, दिस इज C2. तो व्हाट वी कैन डू इज वी कैन रिप्लेस द C1 एंड C2. C1 और C2 को रिप्लेस करेंगे तो कैसा हो जाएगा, दिस इज C एंड दिस इज V, एंड दिस C विल बी, क्योंकि ये सीरीज है तो ये हो जाएगा C1 C2 डिवाइडेड बाय C1 प्लस C2. तो कितना हो जाएगा, C1 C2 दैट इज C इक्वल्स 3 इंटू 2 डिवाइडेड बाय 3 plus 2, 6 by 5 which is 1.2. ठीक है, Basically this is 1.2 is 1200 पिको फराड, ठीक है। लेकिन अब एरर भी चाहिए भैया हमको, तो एरर 1/c इज इक्वल टू 1/c1 प्लस c2 dc by c square is equal to dc by c1 square plus dc by c2 square, ठीक है। ओके तो dc क्या हो जाएगा, dc will be, dc यहाँ पे लिख लो, dc will be c square which is 1200 into 1200 divided by dc by c1 square, तो 10 divided by 2000 into 2000 plus 15 divided by 3000 into 3000, ठीक है। ओके ओके ओके, पहले तो ये 0 0 काट दो भैया, ठीक है, काम खत्म, है ना। तो अब ये है 900 और ये है 400, तो 100 भी उधर लेके चल जाओ, तो 12 इंटू 12 है ना, ठीक है। 12 इंटू 12 डिवाइडेड बाय 100, 10/4 प्लस 15/9 DC, अभी तक केवल DC पे हम लोग, DC इज इक्वल टू 12 इंटू 12 डिवाइडेड बाय 100 इंटू 36, इट्स 90 एंड हियर इट्स प्लस 60। ओके तो ये हो गया, 3 से कट गया, 12 इंटू 150 डिवाइडेड बाय 100 इंटू 3, ये कट गया, ये कट गया, 3 से हो गया 5, 5 इंटू 12 इज 60, 60 इज, दिस बिकम्स 6, ठीक है। तो दिस इज 1200 प्लस माइनस 6 पिको फराड्स, ठीक है। सो दिस इज आवर, है ना, जो अभी C बन गया। नाउ एनर्जी स्टोर्ड इज, ठीक है, तो अब एनर्जी स्टोर्ड आ जाओ, हाफ CV स्क्वायर, तो नाउ व्हाट इज द परसेंटेज एरर, ठीक है। तो ln E इज इक्वल टू ln C प्लस 2 ln V, डिफ्रेंशिएट कीजिए तो डी बाई बी इज इक्वल टू डी सी बाई सी प्लस 2 इंटू डी वी बाई वी। ये कितना हो जाएगा, डी सी बाई सी इज, डी सी बाई सी, अच्छा सी क्या था, 1200 प्लस माइनस 6, तो 6 डिवाइडेड बाय 1200 प्लस 2 इंटू डी वी बाई वी, डी वी इज 0.02 डिवाइडेड बाय 5, ये हो गया खत्म 500, ओके। और ये परसेंटेज में है तो इंटू 100 कर दीजिए भैया, ठीक है। तो दिस बिकम्स 100 इधर चला गया, ये हो गया, तो 6/12 इज 0.5 प्लस 2 इंटू 2 इज 4, 4/5 इज 0.8, तो बेसिकली दिस बिकम्स 1.3%, ठीक है। So the percentage error is 1.3%. Thank you. A person measures the depth of a well by measuring the time interval between the dropping a stone and receiving the sound of impact with the bottom of the well. So this is the well. Okay. Well is L, and he drops the stone. The stone reaches the bottom. So for the stone to reach the bottom, it's under the acceleration due to gravity. So therefore T1 time to reach the bottom. So T1 is equal to root over 2L by G. How we get this equation is actually half GT square is equal to L. So T1 is this. Now again the sound reaches the observer. Okay. after the striking of the stone. So T2 becomes L divided by velocity of sound. This is second. So now T is actually T1 plus T2. This is third. So therefore dt is equal to dt1 plus dt2. Okay. Now this is known to us. dt is how much? 0.01 seconds. Okay, these two we have defined out. Okay, so now if we take this, so t1 is equal to root over 2l by g. So therefore dt1, let us take ln on both the sides. So ln t1 is equal to half ln l plus ln some constant. Differentiate. So dt1 by t1 is equal to half into dl by l plus differentiation is 0. So therefore dt1 becomes half into dl by l into t1. Now what's t1? t1 is root over 2 into 20 by 10, which is 2. So this is going to be half, not 2 and t1 is 2. So this is going to be actually dl by l. Third. Okay, so dt1 is, so put here dl by l plus dt2. So t2 is l by vs. So taking ln t2 is equal to ln l minus ln vs. This is assumed to be constant. So therefore dt2 by t2 is equal to dl by l. This is fifth equation. This one was fourth. Okay, so plus, so dt2 becomes dl by l into t2. So dl by l into t2. T2 is l by vs. L is 220 by vs is 300. So this is 1 by 15. So plus dl by l into 1 by 15. Okay, and this is dt. It is 0.01. Okay, so what we have to find out? dl by l. So dl by l into this becomes 16 by 15 is equal to 0.01. So dl by l is equal to 0.01 into 15 by 16, and in percentage it, you have to multiply by 100. So therefore it becomes almost equal to 1%. So A is the answer. Thank you.
If the measurement errors in all the independent quantities are known, then it is possible to determine the error in any dependent quantity. This is done by the use of the series expansion and truncating the expansion at the first part of the error, जो कि यहाँ पे दिया हुआ है. For example, consider the relation z equals x by y. If the errors are respectively, then this is done, and therefore ये हो गया. Okay. एक चीज़ और लिखा हुआ है, the relative errors in independent variables are always added. So let us solve this for this ratio. Okay, so what we have to do is we have to find delta. So consider the ratio r equals 1 minus a by 1 plus a, and then we have to calculate the error delta r. Okay, so let us solve this. So we'll solve by two methods. First, to method 1. So r is equal to 1 minus a divided by 1 plus a. Okay, so as you can see, the z was x by y, and therefore delta z by z became delta x by x plus delta y by y. Okay, and this is given in the question. This is given. So therefore we can also write delta r by r is equal to delta 1 minus a by 1 minus a plus delta 1 plus a by 1 plus a, and we have to make it, we have to be very clear that this has to be additive. ठीक है, तो जहाँ पे भी wherever negative sign comes, we are not going to subtract, we are going to even add on because there is an additive. So therefore now let us proceed ahead. So delta r by r becomes delta into 1 minus a. So delta 1 is constant, so 1 is not going to change, so therefore it's like 0. So this becomes minus delta a divided by 1 minus a, and this becomes plus delta a divided by 1 plus a. Because the errors are additive, so we'll be including a positive sign. So therefore this becomes delta a divided by 1 minus a into 1 plus a. Okay, and this is 1 plus a plus 1 minus a. So a is gone, it's 2. So 2 delta a divided by 1 minus a into 1 plus a. So this is what delta r by r. So therefore delta r is going to be 2 into delta a divided by 1 minus a into 1 plus a into r. Now what is r? R is 1 minus a by 1 plus a. So therefore 1 minus a and 1 minus a gets cancelled. So therefore this is 2 delta a divided by 1 plus a whole square. So B is the option. Now going and solving by our second method, which is conventional method. Method 2. Okay, so r is 1 minus a divided by 1 plus a. So therefore what we do is we take ln on both the sides. So ln r is equal to ln 1 minus a minus ln 1 plus a. Now because we are like calculating the errors, it has to be additive. Now differentiating on both sides is going to be dr by r is equal to d into 1 minus a by 1 minus a plus d into 1 plus a divided by 1 plus a. Okay, so therefore here again it becomes dr by r is equal to minus dA by 1 minus a, again this will become plus because additive, plus dA by 1 plus a. So this becomes dA by 1 plus a plus 1 minus a by 1 minus a into 1 plus a. A is gone, so this is again 2 into dA by 1 minus a into 1 plus a. Because it was dr by r, so we'll multiply this by r here. R is 1 minus a by 1 plus a. Again we get the same thing, which is 2 into dA by 1 plus a whole square. So this is the method 2, which is actually which we recommend to use, but because since it's already given here, you know how we have to calculate, so therefore we use the method 1 for this part. Thank you very much. The time period is found to be this much. Okay, so since there are 1 2 3 4 5, so let us find the general notation for time period. So this is going to be 0.52 plus 0.56 plus 0.57 plus 0.54 plus 0.59 divided by 5. So this is how much? 2 plus 6 is 8, 8 plus 7 is 15, 15 plus 4 is 19, 19 plus 9 is 28. Okay, and rest everything is 0.5 only. 0.5 plus 0.28 divided by 5. So this becomes 0.5 plus 0.056. So this is 0.556. Now we have to round off this to 2 decimal places. So this becomes 0.56 seconds. And then the error, so 0.56, so the deviation is 0.04, here it's 0, here it's 0.01, is 0.02 and 0.03. So if we add 3 plus 2 is 5, 6 plus 4 is 10, 0.1 divided by 5, it's 0.02. So therefore we have to write time as, that is the time period, 0.56 plus minus 0.02. So therefore the error in the measurement of time is going to be 2 by 56 into 100. So this is going to be like, if we make it 4, so this is 40, so it's 25, so this is 7, so 25 by 7, 7 by 25, 3 is 21, 40, then we have 0.5, 35, we have 50, and then 3.57%. So therefore B is true. Now going ahead. So I know we have already defined B, and now what we have to do is the error in the measurement of R, small r. The small r is 10 plus minus 1, so it's going to be 1 by 10 into 100. This becomes 10%, so this is also true. A is true, B is true, C is false. Okay, now the error in the determined value of G. Okay, so we have to find the error in G. So let us do this. So G is going to be 4 pi square into 7 r minus r divided by, this is G, 5 t square. These all are constants, so therefore ln G is equal to ln r minus r plus, it is minus 2 ln t. So therefore we differentiate, it comes dg by g is equal to d of r minus r by r minus r minus 2 dt by t. Okay, so dr minus, so again we solve it, dg by g becomes dr, because it's going to be additive, so we are going to add here by r minus r. R is 60 minus 10, it's 50 mm, minus 2 into dt by t. So dt by t is anyway 3.5%. So let us do this. So therefore dg by g percentage wise is going to be, so this is going to be 2 by 50 into 100. So this is 4 plus, and it's going to be plus because it's additive, 0.147, so it's going to be around 11.14%. So therefore the D option is also correct. Thank you very much. Energy is given by this formula, so E becomes A square e to the power minus alpha t. Now what we have to find is, we have to find the percentage error in the value of Et. So take ln on both the sides, so it's ln E is equal to ln of A square plus ln of e to the power minus alpha t. So this is going to be ln E is equal to 2 into ln A minus alpha t. Differentiate on both the sides. So this is going to be dE by E is equal to 2 into dA by A minus alpha into dt. Okay. So now this is the equation. So we have to calculate the percentage error in the value of ET. Okay. So let us first calculate the fractional error. So dA by A, okay, and dt. So 2 into dA by A. What is dA by A? It's 1.25% minus alpha. Alpha is 0.2 per second, and now this is dt. So now it's already mentioned that the error in measurement time is 1.5%. So therefore I can write that dt by t is 1.5%. So therefore dt is going to be equal to t into 1.5%, which is equal to, now what is that time mentioned here? Time mentioned is 5 seconds. So 5 into 1.5 percentage. So therefore, now since the errors are going to add, so therefore I am going to put a plus sign here. So therefore it becomes 2 into 1.25 is 2.5 percentage plus 0.2 into dt. dt is 5 into 1.5 percentage. So 0.2 into 5 is 1. 1 into 1.5 is 1.5. So therefore 2.5 plus 1.5, this becomes 4%. Okay. So we have to take care that here we have to like calculate dt, because the in the equation dt is mentioned, dt comes, it's not dt by t and all. Okay. So it's dt is mentioned, so therefore dt we have to calculate. Thank you. Okay, consider a vernier calipers in which 1 centimeter on the main scale is divided into 8 equal divisions. So for vernier calipers, one main scale division is 1 by 8 centimeter, and what is happening, 5 divisions of vernier scale coincide with 4 divisions on the main scale. So 5 VSD is equal to 4 MSD, which is 4 by 8 centimeter. So therefore one vernier scale division is going to be 1 by 2 into 1 by 5, which is 1 by 10 centimeter, 0.1 centimeter. So therefore the least count is going to be 1 main scale division minus 1 vernier scale division, 1 by 8 minus 1 by 10, which is equal to 45 minus 4. So 1 by 40 centimeter, which is 0.025 centimeter. Now for a screw gauge, okay. For a screw gauge, 100 divisions on circular scale are there, and 1 complete rotation of the circular scale moves it by 2 divisions on the linear scale. Fine. So the pitch of the screw gauge is twice the least count of the vernier caliper. So twice into 0.025, this is the pitch, divided by 100 is going to be the least count. 0.05 divided by 100 is centimeter. So 0.0005 centimeter, this is the least count on screw gauge. So therefore it's going to be 0.005 millimeter. So this option is not correct, but this option is correct because it's here 0.005 millimeter. Now it does the least count of the linear scale of the screw gauge, twice the least count. Okay, so for one main scale division is going to be 2 into 0.025 centimeter, which is 0.05 centimeter. Now on one complete rotation, it's 2 divisions on linear scale are moved. So therefore 2 into 0.05 divided by 100, which is 0.1 divided by 100 centimeter, which is 0.001 centimeter. That is 0.01 millimeter is going to be the least count of the screw gauge. So therefore C option is correct, B option is correct, D option is. Thank you. Using the expression 2d sine theta equals lambda, one calculates the value of d, okay, by measuring the corresponding angle theta in the range. So, okay. wavelength lambda is exactly known. So when it is exactly known, so therefore d lambda is going to be 0. So take care of this. And the error in theta is constant for all the values of theta. So as theta increases, so error in constant, that is d theta is constant. So as theta increases from 0 degree. So now let us try to solve this. So we will see in all the options mentioned absolute error in d. So therefore we have to calculate the absolute error in d. ठीक है, तो अब क्या कीजिए? So 2d we can write as lambda by sine theta. We will put ln. So this becomes ln of d plus ln of 2 should be equal to ln lambda minus ln of sine theta. Differentiate it. So this is going to be different, d by d. Differentiation of this is going to be 0 as this is constant. Doesn't there is no it doesn't change. So this also is constant as mentioned in the question. It's exactly known. So therefore we are left with this only. This is going to be equal to, so differentiation of so this is going to be sine theta into differentiation of sine theta is cos theta, and therefore it's going to be d theta. So this is cot theta d theta, and because errors are going to be additive, so I am just neglecting the negative sign here. So therefore d of d is cot theta into d theta. Okay, so now as theta increases from 0 degree and it goes to 90 degree, so what is the value of cot theta? So cot theta from 0 to 90 degree, okay, so tan is like this, so cot theta is actually like this. Okay, so therefore the fractional error in d decreases because the graph of cot theta is like this from 0 degree to 90 degree. So therefore the fractional error in d decreases. Thank you. In the determination of Young's modulus, okay, Young's modulus क्या हो गया? 4mLg by pi l d square. Okay, fine. Basically ये कैसे फॉर्मूला आया है? y equals f by a divided by delta l by l. तो f हो गया mg, a is pi r square which is pi d square by 4 into the entire length and del dl, that is the delta l which is the extension. तो यहाँ पे this l is the extension. Okay, so quantities okay, and load and everything is mentioned in the same way. The number of okay, the contributions to the maximum probable error of the y measurement. Okay, तो y, तो अब ये पूरा चीज हमारे पास है, we know this. So therefore what we are going to do is we are going to take ln on both the sides. So therefore ln y is going to be ln m plus ln l plus ln g minus ln small l minus 2 ln d, and ln of some constants is going to be there. We are going to differentiate it. So dy by y is equal to dm by m plus dl by l plus dg by g, and because it's like error is going to be additive, so I am excluding the negative sign here. So dl by l plus 2 into d of diameter by d. Now, so the maximum probable error of the y measurement due to the error of measurement of small d and small l are the same. Okay, small d and small l. So let us find out. So here it's mentioned that the quantities d and l are measured using a screw gauge and a micrometer respectively. They are the same pitch of 0.5 millimeter. Number of divisions is 100. So therefore, like the least count is going to be 0.5 divided by 100 millimeter. So this is 0.005 millimeter. This is the least count. Okay. So therefore, okay, let us find out, for the contribution from small d and small l. So contribution from small d is 2 into, okay, so like we have calculated d and l from both this. So this is 2 into 0.005 millimeter divided by d. What is d? D is 0.5 millimeter. Okay, and for this is going to be dl by l. So again 0.005 millimeter divided by l. L is 0.25 millimeter. Okay, so as you can see, so if we like kind of divide here, so it's going to be 0.25 only. So therefore, yes, the contribution is same. This is true. So A part is true. Due to the error in the measurement of D is twice that of the measurement of L. Okay, so maximum probable error of the Y measurement, okay, due to the error of measurement of D is twice that due to, no, this is same only, no? Okay, due to the error of the measurement of small l is twice that, no, again that is wrong. Due to the error in the measurement of small d is 4 times, no, this is also wrong. So therefore the answer is only the first one. Thank you. The density of a solid ball is to be measured in an experiment. The diameter of the ball is measured with a screw gauge whose pitch is 0.5 and there are 50 divisions on the circular scale. So therefore the least count of the screw gauge becomes 0.5 millimeter divided by 50. So it's 0.1 divided by 10, which is 0.01 millimeter. This is the least count of the screw gauge. The reading on the main scale is 2.5 millimeter and that on the circular scale is 20 divisions. If the measured mass of the ball has a relative error of 2%, okay. So reading on the main scale is 2.5 millimeter and then on circular scale. So 2.5 millimeter plus 20 into 0.01 millimeter. This becomes 2.5 millimeter plus it's 20. So therefore it's going to be 20, so it's 2, sorry, it's 0.2 millimeter, it's 0.20 millimeter, so therefore it's going to be 2.70 millimeter. This is the diameter, okay, and plus minus 0.01 millimeter. Okay, so so now if the measured mass of the ball has a relative error of 2%, okay, then the relative percent in density. So density is going to be rho is equal to mass by volume. So mass divided by 4 by 3 pi r cube, where we'll take density diameter here, so d cube by 8 and 8 will go here. So therefore d like differentiate, take ln on both the sides, so ln rho is equal to ln m okay plus 3 ln d by d, and there will be ln of constants. Differentiate, so d rho by rho is equal to dm by m plus 3 into d of d by d. Okay, so now d rho by rho, the relative percentage in the density, so this is going to be dm by m 2% plus 3 into, it's 0.01 divided by 2.7 into 100. This becomes 270. Okay, so it's almost 300 divided by 270. So it's 10 divided by 9. so it's almost 1.11 percentage. So 2% plus 1.11% is 3.11%. So basically, which is equal to 3.1 percentage. Thank you. A student uses a simple pendulum of exactly 1 meter length. So length जो है constant है. Okay. So dl is going to be 0. Make it very clear. To determine g, the acceleration due to gravity, he uses a stopwatch with the least count of 1 second. For this records 40 seconds for 20 oscillations. So time period for 20 oscillations is 40 second plus minus 1 second. So therefore time period of one oscillation is going to be 40 divided by 20 seconds plus minus 1 by 20 seconds, which is going to be 2 plus minus 0.05 seconds. This is the time period for one oscillation. Okay. For this observation, which of the following statements is not correct? Error delta t in measuring time period is, so time period, the error is going to be 0.05 by 2 into 100. Okay, percentage. Okay, here this is about delta t only. So delta t is 0.05 seconds only. We are not calculating percentage. So A is correct. So this is wrong, because this 1 second was for how many? 20 oscillations. So therefore this is true. Percentage error in the determination of G is, okay. So time period is going to be 2 pi root over L by G. So therefore G becomes 4 pi square L divided by T square. Okay, so now we take ln on both the sides. So ln G is equal to ln of 4 pi square plus ln L, and this is minus 2 ln of T. Differentiating dg by G is equal to, so this differentiation is going to be 0 because it's a constant. Now ln L is constant, so therefore dl is going to be 0. So minus 2 ln of T, minus 2 into dt by T, and because it's error, so it's going to be positive. So therefore dg by G, we are now calculating in percentage. So this is going to be 2 into dt by T. So what's dt? So it's 0.05 divided by T, that is 2 into 100 percentage. So this is 5 percentage. So therefore C is the answer, D is the answer. So A and C are the correct options. Thank you. A student performs an experiment to determine the Young's modulus, okay, by Sear's method. The Sear's method is y is equal to f by a divided by small l, that is extension, by capital. Okay, so therefore we can write here y is equal to f by a is area of cross section, so 4 pi d square into capital L by small l. Okay, so now the student measures the extension length of wire, and the exactly 2 meter long. So therefore we can write dl is going to be 0. Okay, length of the wire is this much with an uncertainty of this much. Okay, load is exactly 1 kg and G is also exact. So therefore dF is also going to be 0 because F equals mg. The Young's modulus obtained is, okay. So therefore what we do is we take ln on both the sides. So ln y is equal to ln of 4 by pi plus ln f minus 2 ln of d plus ln of capital L minus ln of small l. Differentiating on both the sides, so dy by y is equal to, because this is constant, the differentiation is going to be 0. This constant, again differentiation is going to be 0, and this is also constant, so again differentiation is going to be 0. Since the errors is going to be additive, so therefore we can write 2 into ln of 2 into dt by d plus d of small l by l. So therefore dy by y becomes 2 into, now let us say, extension in the length of the wire, and diameter is 0.01 divided by 0.4 plus dl, which is uncertainty of 0.05 by 0.08. So let us calculate this. This is going to be 2 into 1 by 40 plus 5 by 80. So it's 1 by 20 plus 1 by 16. So if we calculate in percentage, this is going to be in, like, we multiply by 100. This is 5 plus 116. So 25 by 4, that is 6.25. So this is 11.25 percentage. So therefore dy is going to be 11.25 percentage of y. So if you see the Young's modulus here, it's, in all the options 2 is there. So now let us see that where the error is going to be around 11.25%. So here the error is 0.3 divided by 2 and 200. So this becomes 30 divided by 2. This is 15%. Here it's 10%. Here it's 5%, and here it's like even less than 5%. So B is the option, which is nearmost option to this. Thank you. A student performs an experiment for determination of G, okay, and L is 1 meter, and he commits an error of delta L. For T, it takes the time of n oscillation of the stopwatch of least count delta T, and he commits a human error of 0.10. For which of the following data the measurement of G will be most accurate? So G is 4 pi square L divided by T square. So therefore ln of G is going to be ln 4 pi square plus ln L minus 2 ln of T. So if we calculate the error by differentiating, so this is going to be, the differentiation of this is going to be 0. dl by L minus, because errors are additive, so therefore I am putting 2 plus dt by t. Okay, so now let us calculate how things are going to happen. So the measurement of G will be most accurate in which, okay, so for T, it takes the time of n oscillations with the stopwatch of at least, okay. So for n oscillations, it's T plus minus delta T. So therefore for one oscillation, it's going to be T by n plus minus delta T by n. Okay, so dt becomes delta T by n, and T becomes T by n. So therefore both are going to cancel each other. Okay, so dl by L plus 2 into delta T by T. Fine. So now let us see which is going to be most accurate. So dl by L, okay, so it's 0.5 divided by 1. Okay, now delta T is this much, so 2 into delta T by T, so it's going to be 0.1. Okay, so N actually hardly matters, so it's going to be most accurate. So most accurate is actually, if you see, it's D number. Okay. So if, because n actually doesn't matter, so just we have to add 2 into delta L by L plus delta D by T. Okay, it's 2 is here. So 0.1 plus 0.1, it's 2, 0.2 here. But it's 0.5, 0.5, everywhere is 0.5. So therefore, D option is correct.